So I just want to make a video going over my level editor that I made in Java. I like to do this because I like to take a break from Godot sometimes and also just learn stuff about coding languages that are used in the industry. So I just like to make some sad projects and stuff, and the project in Godot right now is my main project, but this is just a little side one I was working on for a bit. And it's a level editor. So look, so basically, if you move the arrow keys are what move you around in the array, and yeah, and the grid just like displays a set amount of pieces. You could call that like the camera in a way. And on the side, if you notice, there's some tiles, and this is like from a PNG image that I have, and I just like draw them on the side just so you know which one you're selecting. And then so you use the WASD keys to select all the tiles, and right here I'll just select the red blocky ones, and yeah, you can just place them. I'll select the blue ones, and bam. So it's pretty cool actually. And you could just like put tiles anywhere, and it's pretty easy to mess with. Right now the saving's a little bad, but I'm waiting to like mess with it any further until I start actually making the game, because I want to make a game for Android Studio, and this is gonna be the level editor that I'm gonna use for that. So the whole editor is a one-dimensional array of size 64 by 64. It's displayed as a 2D array within the graphical space, and the grid shows about 19 spots by 13 spots at a time. So you can imagine that as a program's camera. And right here, look, you can move all the way back to 0, and I forgot exactly where I placed those. Yeah. So you're able to move around within the array, and I made a little algorithm so that when you move and you place tiles, it'll actually end up in the right spot of the array rather than just in a 19 by 13 array grid. These tiles are actually just IDs because 0 is empty. These are all zeros, and this is a 1, 2, 3, 4, 5, 6. But yeah, so those are what the IDs are, and it's pretty cool. Right here, I don't have it yet to where like it'll like cut out that part, but I don't really care as long as I just don't, because like when I make the game, those are just gonna be like empty spaces, and those are gonna be filled spaces. I know in Android Studio I'll probably figure out a way to cut out the slack, but yeah, because yeah, so that's just pretty sweet about all this. Like I'm just making a bunch of like little blocks and everything. It's actually pretty cool so far. That's why I'm liking it. I'm liking how the project's turning out, and bam. And if you click save, see right here, it printed out that I saved correctly, and it tells you where it is in your thing. So let's see here too. Yeah. So here's level 6 right here. That's where I just edited, and you can see it right there in the text file. And basically what I'm gonna do is I'm just gonna like save that text file, move it over to Android Studio where my project is, and then just like load the level that way, and just kind of put it within the program. And yeah, I'll have it parse through the whole like thing. So maybe, wait, let's call open it again. So maybe like whatever's 0 will be empty, and whatever is filled or has a number that's greater than 0 will be filled by a block. So it's pretty nice. Okay, so to the code. So within the grid to move up, down, left, and right, I use a key pressed. So I use a class called keys that implements key listener, and all it does is just like listen for keys that you press. And if a key is pressed, then you get you check the e.key code, and then I go through a switch statement that just checks all of them. So you can't really press them both, like both the WASD keys and the up, down, left, right keys at the same time, but I don't really care about that. I just want it to like, just be kind of fast. So the right key increases the position X, and the left key decreases the position X, and the up key decreases position Y, and the down key increases position Y. You have to do it this way because with the Y-axis, because the Y-axis, like the further you go down on a computer screen, the further you go up on the Y-axis on a computer screen. And yeah, just so right there, that's pretty simple. Here's where it gets a little tiny bit more complicated. So I have a sprite sheet class that it just holds like whatever, like whatever like a tile there is, and it just like it holds the spots of the sprite sheet, and the sprite sheet is placed on the right side of the screen. So right here you can see that I'm moving through them just fine, and I move them around with the WASD keys in the key listener class. And so when you press the W key, that basically moves it up through the sprite sheet. You subtract by 4, and then you check if it's less than the selected sprite value is less than 1, and if it is, then they set equal to 1 because that's the lowest spot there is in the sprite sheet, because you don't want it to go below 1 or else you'll go outside of the bounds. And after that, put that value within the sprite sheet class. And bam. So all the other ones do very similar things, but A and D were much easier to implement because they're only moving up and down by 1, and then you only check if say like the sprite value is greater than 1. You don't really have to do any other nonsense like send it to the max or minimum. And yeah, so all A does is just subtract the sprite value minus 1, and then you put that value into the array. So you have to subtract 1 when you put that into the sprite sheet. The next two are basically just the opposite of the W and A keys. So the S key will add by 4 instead of subtracting by 4, and the D key will add by 1 instead of subtracting by 1. So just to show you, here's the data array. I will scroll up to it, and right here, the data array, and I'll just like control F through the project, looking through each data array. So I just set to the array width times array height, so it's a one-dimensional array, even though it looks like a two-dimensional array within the program. And yeah, so if the index is 0, then all it draws is just a white piece. Else, if the index is like something other than that, then you get one of the sprite sheet pieces. And let me see. Yeah, and right here, here's where I set it to the selected sprite value, which I just showed you a little bit ago. So the selected sprite value you can see is an ID. It's a tile ID that you're placing, and you place that within the array. So it'll be something other than 0, like a 1, 2, 3, 4, 5, or 6, since I have 6 pieces right now. And yeah, and right here, if the right mouse is clicked, it just sets that spot into the array equal to 0. And then, yeah, and that's it. So the algorithm that I came up with to select the right spot is I made like a true index X, and I get the whatever the piece index is, and I increase it like so. The grid piece goes up to like 19 spots, and I add the position X to that. So basically, when you're in the grid, so you have a 0 to 19 spot, and if you so right here, right now, it's this is a position that you're at position 0 on the x-axis and position 0 on the y-axis, and yeah, so if you go through it, so right here I'm selecting spot 17, but if you start going up, it's still basically spot 17, but you're at position 12, which is right here, so you're adding 12 to that, and so that means that spot 29 instead, which would be like the 30th spot in the array. So yeah, so that's what's happening. The same thing on the y-axis. So like each time you move the arrow keys, you're actually moving the position in the array. And then since the camera is about 19 spots, it'll go 19 spots above the x position and 13 spots above the y position. So that's the max you could go at a time until you like move to the right spot in the array. So yeah, it's the simplest little algorithm, but it did take a little bit of thinking to actually try to implement. But yeah, and as you can see, I put that true index plus the true index y times the array width, because that's how you parse through a single dimension array as a 2D array. So it's kind of just like, it's a lot faster than actually just using a normal 2D array. I learned this off of a YouTuber that I did not actually learn that from college. No one ever told me about that, so I did not know that two-dimensional arrays were slower. It's a lot faster just to use a one-dimensional array. But yeah, hope you guys all have a great day.